Hey everyone, welcome back to my another logistic regression tutorial, and I'll continue from my last tutorial, and in this tutorial we'll write second part of it. And in previous tutorial we defined our model structure, learned to compute a cost function and its gradients. And in this tutorial we'll write an optimization function to learn data parameters using gradient descent. We'll write the optimization function that will learn W and B by minimizing the cost function G. And I should mention that one of the reasons we use a cost function for logistic regression is that it's a convex function with a single global optimum. You can imagine rolling a ball down the ball-shaped function, and for example, imagine in this image rolling a ball. It would settle at the bottom, doesn't it? It would. So similarly is to find the minimum of the cost function. We need to get to the lowest point. To do that, we can start from anywhere on the function and iteratively move down in the direction of the steepest slope, adjusting the values of W and B that lead us to the minimum. For this we'll use following two formulas. So as you can see, we should calculate W and B and to reduce a loss to get into the center of that slope. So in those two formulas, the partial derivatives WV and dB represent the effect that a change in W and B have on the cost function, respectively. By finding the slope and taking the negative of the slope, we ensure that we'll always move in the direction of the minimum. To get a better understanding, let's see this graphic. So as you can see, this is a slope. So when the derivative term is positive, we move in the opposite direction towards a decreasing value of W, and the derivative is negative, we move in the direction of increasing W. Thereby ensuring that we are always moving toward the minimum. So it's here to the face. The alpha term in front of the partial derivative is called the learning rate. So alpha was here, alpha. So it's called the learning rate and is measuring of how big a step to take at each iteration. The choice of learning parameters is an important one, because too small step and the model will take very long to find the minimum. If step is too large, and the model might overshoot the minimum and fail to find this minimum point. So gradient descent is the essence of the learning process. Through it, the machine learns what values of weights and biases minimize the cost function. It does this by iteratively comparing its predicted output for a set of data to the true output in training process. So that's should be it. Shortly talking, our D and B should chosen that our cost will be at this happy face point. So anyway, we can move to the code because I don't want to go deep into theory, and if you didn't understood something, you can read it on my website. So let's do this further. So in this tutorial we write also another function, and we won't need this anymore, at least for now, and we'll implement our optimization function. So I'll call it define optimize function, and inside there will be a W, B, X big and I big, the same as in previous tutorial, but at least right now we'll add more parameters. So it will be number of iterations, learning rate, and of course print cost. I'll declare it false as default, and okay, let's move. We'll create a cost error list and we'll place there a cost numbers. So now I can zoom in if you need. So now I'll write a function. Here we use a for loop. So this is for learning iterations. So for I in range of num iterations, we'll calculate a propagate. So it means grads and cost will be actually equal to propagate. And here we'll place our W, our B, X, and I. So this should be small b. So we'll use this our propagate function we made. So is forward and backward propagation. We'll calculate this and we'll return it with grads. And of course we'll calculate a cost in a simple way. So right now we will take them off from this dictionary. So dw will be equal to grads, and here will be a dv, and here will be similar but db. So we retrieve derivatives from grads this way. And now we will use our function we wrote here, both of these functions. Just look how it's much simpler than it looks here as mathematical expression. So w is equal to w minus learning rate multiplied by dw, and similar line will be made for b, bias, db. Okay, actually we already wrote everything we need, so now we'll record the cost. So if our I divided by 100 is equal to 0, we'll add a cost to our list, just like that. And yeah, and another is our print function, so we can track our training. So if our print cost is equal to true and I divided by 100, oh sorry, it should be smaller I, and I divided by 100 is equal to 0, so we'll use a print our cost function. So this is simply a cost after iteration. So here will be our I, and here will be our fee. And now let's just add both of them, I and cost. So that's it for our for loop. And now we need to update our parameters. So params will be equal to w equal to w, and just something like that. B will be equal to b, and we do the same for our grads. Well, similar, not the same. Grads, so will be dw equal to dw, and dw, db equal to db, just like that. What else we need? So also we need a return function. So we'll add a return params, grads, and costs. Here should be costs. I made a small mistake, sorry, not to duplicate them. So that's it. We wrote our optimize function as we loop our for loop, and if you don't understand, what we do is here that we use W and B here and X, Y, and every time we use this we receive a dB and dW, and we calculate this and we return back again to this propagate with new values. And every time we do the same stuff, and every time we recalculate the cost function, which is here. And as I said, we want our cost function to be in this place. That's simple. So what we can do now is we can test our code with the same values we had here. We don't need to change them, and later in the next tutorial we'll do everything with real values, images. So here what we do is params, grads, and costs is equal to optimize function, and here we just write W, B, X, Y, 100 of iterations, learning rate will be something like that, and print cost equal to false. Okay, and now we just print something like params, and here will be our W. Next we'll copy this, here will be our B, and here should also be grads, so dW and dB. Yeah, I think that's it. Let's build this and we'll see. And yeah, something wrong here, and I don't know why, because of this maybe. Yeah, and as you can see, you should have received, if you copy my code, you should receive something like these values. So here is W, here is B, here is dW, and here is dB. That's simple. So we know that our both codes work, both functions, so this, and now we have a loop, and that's it. So in this tutorial we learned how to update learning parameters. It's gradients and descents. Gradient descents. You saw how we use parameters from forward and backward propagation to teach our model. So in next tutorial we'll write function to compute a prediction. So we'll actually make a prediction. So keep following my tutorials, like me on YouTube, subscribe my channel, and keep watching my videos. So thank you all for watching, good luck, and see you in a next tutorial. Goodbye.